Welcome to Carlton's Math Corner. Today we're going to continue our study on inequalities. Please make sure that you have your math journal, something to write with, as well as vocabulary packet. Our target today is I can graph a system of linear inequalities. First of all, let's talk about what is a system of inequalities. It is a pair of inequalities that share the same solutions. So here are two inequalities, and they are graphed below. What do you notice? Well, I noticed that one of the lines is dotted. The other one I notice is solid. The other thing I notice is they are shaded. One is shaded off to the right, and the other one but it's kind of like up and to the right, and this one is shaded down and to the right. I also notice that there's three different colors, and I would like to know why this one right here is green, because I know blue and yellow make green, so there must be some overlapping going on. And what does that mean in this graph? And we're going to learn that today. So first of all, when we're given a system of inequalities, we need, to put them in slope-intercept form. Like, that's our first step, because we need to graph them and then kind of shade where their solutions are. And so in order to graph them, what I'm going to do is I'm going to get, this one for sure is not in slope-intercept form. This one is, though. I can leave that one alone. But I'm going to make this one in slope-intercept form. The first thing I'm going to do, though, is get rid of that 2x. So if I do the inverse and I do minus 2x, that will bring it over to the other side. Now it's on the right side, and then now I have to get rid of that 3y. So what would I do to get rid of that 3y? Yep, I'm going to divide, and actually I'm going to divide everything by 3. And so if I divide everything by 3, now we have y is all by itself. Good. And did we divide by a negative? Because remember, when you divide by a negative, what happens to the inequality symbol? It flips. Well, the 3 was positive, so we don't have to worry about that one on this inequality, but keep that in mind for future inequalities. So the less than will stay the same. And then remember, we have negative 2x, and it's being divided by 3, so really it's 2/3 x, and then plus 1. Now we have it in slope-intercept form. Okay, and then the other one is still just y and less than or equal to, and this is really, what's really next to that x? A negative 1, and I could put it over 1 just to make it easier to graph them for you, and I want you to look at this. So the first one, remember, we start off with our y-intercept in order to graph, and so I started off with the plus 1, so here's plus 1, and then I went down to 1, 2, sorry, there's plus 1, 1, 2, and then over 3, 1, 2, over 3, 1, 2, over 3, and this is the line that I got. Why do you think it's dotted? Yep, it's just like what we did, when we're graphing, just graphing even less than or greater than. Remember, it's always an open dot. Same thing is true with graphing a linear inequality, where anything that is less than or greater than will have a dotted line. Okay, because that means we want all the solutions that are really close to that dotted line, but not quite lying on that dotted line. We can't have any ordered pairs. None of those are solutions to this equation, or not equation, but inequality. Now, if you look at the next one, this was plus 0, so I started at plus 0, and then I went down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, and this one is a solid line because this one has the or equals to. So this is less than or equals to. So it could be any of those solutions as well as less than that. Now we need to talk about shading because our shading is going to be, it's going to depend on what this inequality symbol is. And the first one is a less than symbol. And so that means that we are going to, I always use the y-axis as a guide. If I'm looking for solutions that are less than, then that means that I need to shade underneath on the y-axis. And what that means is I'm shading underneath this line. And I am going to shade all the way across, everywhere underneath this line. So I use that y-axis just to find kind of where to shade. And it looks like we're shading kind of underneath and off to the left because we want values that are less than. That means basically for this line alone, all the solutions for that inequality is basically every single ordered pair that's in this shaded line. So every x and y coordinate would make this one true, this inequality true that's in this area. Now if I take a different color and I shade this inequality, this one is also less than. So I need to look at the solid line and I am going to shade underneath. And I want you to notice that actually both these lines are very similar on where they're shaded. However, there's one part that's turning green. What do you think that part represents? Yeah, the part where they overlap is actually the solutions. These are all the solutions to that system of inequalities. So everything it can't be in this little area because this little area only has blue and this little area only has yellow. So this area that's green is actually all the solutions that would make both of these true. Meaning, if I plugged in, so if I look at this, if I take one of these ordered pairs, if I take this ordered pair, which would be -2, 0. So if I plug in 0 or -2, 0, okay, so -2 is x, because that's not, we went over on the x-axis, -2, and we stayed at 0, that's y. So if I plug in -2 for x, and I plug in 0 for y, look what happens. -2 thirds times -2. Well, -2 times -2 is 4, so it'd be 4 thirds. Or 4 thirds is the same as 1 and 1/3. Well, what's 1 and 1/3 plus 1? 2 and 1/3. Is 0 less than 2 and 1/3? Yes, it is. That actually works. What if I put in -2 for this one and put in 0? What's -1 times -2? +2. Is 0 less than or equal to +2? Yes, it is. So it works. And that's what's important is we're trying to figure out what works. Everything that's in the green section or the overlap section, because I know you're going to be using pencils. Some of you will use highlighters, which I highly recommend if you have two different colors. Then you could really see where they overlap. But the section they overlap are the solutions that make it work. Okay? So look at our steps. So what did we do? We wrote it in slope-intercept form, both inequalities. Well, sometimes, this one was already in that form, so we were able to start off with just graphing that one. But once it's in slope-intercept form, then remember you plot it with your y-intercept. And then we plot the rise over the run. So we plot the slope. Then we use dotted line. Remember if it's greater than or less than. Solid line if it's less than or equal to or greater than or equal to. Okay. Remember though that the line or the sign flips when you divide or multiply by a negative. Okay, so remember that because sometimes it flips. Okay, then we're going to shade, and the way that we shade, whoops, is we follow that y-axis. We either shade below, like if it's less than, and off to the left, or we shade above and off to the right. And then after we do that, then we just check to see where they overlap. And those are the solutions. Okay, and so what I would like you to do is I want you to take these steps and I want you to do one problem. So here is the one system of inequality, and I want you to try this problem. Remember, slope-intercept form first. Make sure if you divide or multiply by a negative, the sign will flip. So remember that, okay? And then shade it and see where do they overlap. Use highlighters if you have them, and if you don't, that's okay. Maybe you shade, sometimes I use like different types of shading, like I'll do light shade for one of them and then really dark shade on another one. Or sometimes I use lines, on one of them, and then on the other one I use like stripes going the other way. So lines going one way, and then for the other one I do lines going the other way, so then I can see where they overlap. You should be able to see where they overlap no matter how you do it though. Well, thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again. Have a great day. Bye.